today we're going to look at implicit differentiation, and this is a topic that's specific for Leaving Cert higher level maths, so it's not on Leaving Cert ordinary level course, so it has no crossover whatsoever. It's really important to note that what it is firstly is that it is the process of finding the slope of a tangent to a circle at any point, so not just a slope. It has to be a circle. And despite this topic being on the course since 2015, up to 2020 it has not yet featured in the exam paper. So it hasn't featured at all in the papers from 2015 to 2019. It has only ever featured in one mock exam, so not in the real thing at all. So we're going to be looking, like I said, at finding the slope of a tangent to a circle at any point. So I have a few examples here. The first thing I want to do is I want to get you used to how to differentiate the circle function itself. So having done your study of the circle already, we should know the three types of circle equations. So the first one is x squared plus y squared equals r squared. That's this one. The other one, or the next one, is a circle equation in this form, which is x squared plus y squared plus 2gx plus 2fy plus c equals 0. And the third one is your x minus h all to be squared plus y minus k all to be squared equals 36. From our study of a circle, we should know them three different ways of writing the equation of a circle. So the first one we're going to look at is the x squared plus y squared equals 81. So I want to just get you used to, like I said, how to differentiate. So if we have x squared plus y squared equals 81. So we're going to use the chain rule to differentiate a circle equation, okay? And the chain rule here can be a little bit complicated to explain, so it's kind of like a shortcut which I'm going to teach you. You're going to differentiate everything, but every time you differentiate a y term, you're going to put dy dx beside it, okay? So to differentiate this is going to go to 2x. This is a y term and it's going to go to 2y, but because it's a y term I have to put dy dx beside it, equals, and the number 81 differentiates to 0. Okay, after you do this, you want to try get dy dx by itself on one side of the equals, because the question did ask to express dy dx in terms of x and y in the following circles. So the next line will be 2y by dy dx is going to equal minus 2x, and then I'll have to divide across by 2y in order to get the dy dx by itself, so I'll end up with dy dx is going to equal minus 2x over 2y, which if you want to, you can divide top and bottom by 2 and you'll end up with minus x over y. So you've answered the question, which was to express dy dx in terms of x and y in the following circles. Okay, the next circle on the PowerPoint is to express dy dx in terms of x and y in this circle here. So x squared plus y squared plus 4x minus 6y plus 11 equals 0. So we're going to look at that one next, and that's going to be x squared plus y squared plus 4x minus 6y plus 11 equals 0. Okay, so just like before, we're going to differentiate, but every time I differentiate a y term, which will be this one and this one, I need to put dy dx beside my derivative. So we'll differentiate 2x, or x squared, that will go to 2x, plus 2y, because this differentiates to 2y, but I must put dy dx beside it because it's a y term, plus 4, because this differentiates to 4, minus 6, but I must put a dy dx beside it because it's an x term, plus 0 equals 0, because 11 will differentiate to 0. So again, all you want to remember to do is differentiate every single term in the circle, but every time you differentiate a y term, put dy dx beside your derivative. Okay, so again, because dy dx is the expression that will help me find the slope of the tangent to the circle, I have to get dy dx by itself. In this question, however, dy dx features twice, so I'm going to have to end up highest common factorising in order to get to dy dx by itself. So I'll bring everything that doesn't have a dy dx with it across the equal sign. So you'll end up with 2y dy dx minus 6 by dy dx is going to equal minus 2x minus 4. That's just bringing the 2x and the 4 across. And then I'm going to highest common factorize the dy dx out of these sides. So dy dx by 2y minus 6 is going to equal minus 2x minus 4. And then finally you'll divide across by your 2y minus 6, so you'll have dy dx will equal minus 2x minus 4 over 2y minus 6. If you want to, you can divide everything by 2 because 2 will divide into absolutely everything over here. You don't have to, but if you want to, you can. If you did, you'd end up with minus x minus 2 over y minus 3. It's up to you. Alright. The third one is then this one here. So this is your circle equation in the form x minus h all to the squared plus y minus k all to the squared equals 36. When you're doing this one, the best thing to do is actually multiply it out first and then differentiate. So you want to multiply it out first into the form x squared plus y squared plus 2gx plus 2fy plus c equals 0, and then differentiate like we did before. So we'll do that one next by multiplying out first. So it is x minus 8 all to be squared plus y minus 2 all to be squared is equal to 36. So that's going to go to x minus 8 by x minus 8 plus y minus 2 by y minus 2 equals 36. We'll end up with x squared minus 16x plus 64 plus y squared minus 4x plus 4 equals 36. If you're someone that needs to split the brackets, just make sure you get it right. That's the most important thing. If you're not that quick at multiplying out, that's okay. And always remember that too. So x squared plus y squared minus 16x minus 16x, oh that should be a y, sorry, minus 4y. So minus 16x minus 4y plus 64 plus 4 is plus 68. Minus 36 will be plus 32 equals 0. Alright, and now I'm back to my circle equation that's similar to example 2, and so I'll differentiate again. I'll differentiate this, it'll go to 2x, y squared will go to 2y, but remember because that's a y term I have to have dy dx with it. Minus 16 minus 4, but again I have to have dy dx with that because that's an x term, and then plus 32 will just go to 0, so I'll have it equal to 0. And I'll finish it off in the exact same way that I finished off my example 2. So I'll have 2y by dy dx minus 4 by dy dx is going to equal minus 2x plus 16. Highest common factorize out dy dx, and I'll multiply that by 2y minus 4 will equal minus 2x plus 16. And finally you'll have dy dx is going to equal minus 2x plus 16 all over 2y minus 4. And again, if you want, you can divide everything across by 2 because 2 goes into everything, and so you'd end up with minus x plus 8 over y minus 2. But you must remember that doing this is optional. If you finished here, you would get your full marks. Okay, so then first 3 examples are just showing you how to actually find dy dx from any type of circle equation. The type of question that I can imagine would come up would be one like this, where you're actually asked to find the slope. Because remember, in the 3 examples that we just did, you weren't asked to find the slope, you were just asked to find dy dx. But because we have no past exam paper questions to go off of, the only kind of prediction would be that the question will say to actually go and find the slope of the tangent to the circle. So you have x squared plus y squared equals 8 at the point 2, 2. So we want to find dy dx here obviously first, and then we want to find out what the slope actually is at the point 2, 2. So x is 2 and y is 2 as well. So if we looked at our circle equation, it is x squared plus y squared equals 8. So I want to differentiate this because remember my first derivative is going to help me find the slope of a tangent. So this will go to 2x plus 2y, but because that's a y term, I must put dy dx with it, equals 0. Okay, So dy dx, or 2y by dy dx, is going to equal minus 2x. So dy dx is going to equal minus 2x over 2y. And now they want me to find the slope of the tangent to the curve at the point 2, 2. So if they're looking for the point 2, 2, this is my x coordinate and this is my y. So I want to sub my x coordinate in for x and my y coordinate in for y. So that means dy dx is going to equal minus 2 by 2 over 2 by 2, which will be minus 4 over 4, which will be minus 1. So I can say that the slope of the tangent to the circle at the point 2, 2 is minus 1. Okay, and that's really important. And the last one here in this is the same type of question, but just you have a different circle equation. You have this type of circle equation here. So again, that's one that we need to multiply out. And after we multiply out, we then find dy dx. But then I'm going to be subbing in 0 for x and 2 for y. So find this of x plus 4 all to be squared plus y minus 3 all to be squared equals 17. So that's x plus 4 all to be squared plus y minus 3 all to be squared equals 17. So that's going to go to x squared plus 8x plus 16 plus y squared minus 6y plus 9 is equal to 17. Tidying up, I'll get x squared plus y squared plus 8x minus 6y. 16 and 9 is going to be 25, and then I'm going to subtract 17, so that's going to leave me with 8, and that's going to equal 0. So, need to find dy dx. I'll differentiate everything, and remember, once again, anytime I differentiate a y term, I must put dy dx with it. So this is going to go to 2x plus 2y, but dy dx goes with it, plus 8 minus 6, but dy dx goes with it because it's a y term, and then 8 will differentiate to 0, so I just have 0 and then equals 0. So I'll have 2y by dy dx minus 6 by dy dx is going to equal minus 2x minus 8. And so highest common factorising out dy dx, 2x minus 8. So dy dx is going to equal 2x minus 8 over 2y minus 6. And the point they want me to find the slope is 0, 2. So I must replace x with 0 and y with 2. So that's going to go 2 by 0 minus 8 over 2 by 2 minus 6. So I'll end up with minus 8. 4 minus 6 is minus 2. So the slope of the tangent to the circle at the point 0, 2 is 4. Okay, really, really, really important. Now, because there's no past exam paper questions to give you here, or anything like that, the only book that I have that has questions is Active Maths. So Active Maths, book 1, page 350, 351, question 1 to 8. Okay, that's the only book where there seems to be some practice questions on implicit differentiation. Really, really important that you get them done because they're the only practice you have for this topic that's yet to be examined on the actual Leaving Cert.